We present an as rigid as possible approach for real-time simulation of solid with oriented particles. Our method copes with 1, 2, and 3-dimensional deformable bodies robustly with a small number of particles. The bar is twisted and manipulated by a position orientation constraint. We used only 20 particles connected serially. Nevertheless, the simulation result is interesting. We release the constraint. The bar deforms under gravity. In the next experiment, we simulate 3 elastic bars with different stiffness values. The green and blue bars are 2 and 4 times stiffer than the red one. The material stiffness is simulated properly. In our method, the material stiffness is largely independent of the iteration count. The numbers of the iteration count are 10, 100, and 1000 in the red, green, and blue bars, respectively. In the original oriented particles approach, the material stiffness is dependent on the iteration count in contrast to ours. Moreover, a large iteration count is required to simulate a moderately stiff bar represented with the serially connected particles. In our method, the smaller the time step size gets, the more responsive the simulation becomes. Nevertheless, the stiffness is also largely independent of the time step size. The numbers of sub-time steps are 1, 2, and 3 in the red, green, and blue bars, respectively. The next experiment demonstrates the robustness of our method. At the beginning of the simulation, all particles were placed to coincide with the center particle. We fixed the position and orientation of the center particle during the simulation. The dinosaur returns to its rest pose rapidly from an extremely deformed pose. Now, we release the center particle. The dinosaur falls down on the floor under gravity. The dinosaur in the rest pose falls down on the floor. Our method can simulate 2-dimensional models. We use 2 position constraints to attach a deformable sheet to a rigid rod. A deformable bunny falls down on the sheet. The 4 corners of the sheet are constrained with the position constraints. We drop 2 bunnies with slightly different friction. The friction is slightly higher in the right. The proposed technique was implemented as an Autodesk Maya plugin for content creation and offline rendering. This scene is composed of 36 deformable models with approximately 2,500 particles and 8,000 edges for the deformation graphs. The deformable models can be exported into a standalone application for real-time simulation and rendering. The simulation is performed with a simple parallelization using OpenMP and GPU skinning. This video shows the real-time screen capture. The simulation runs at over 50 frames per second with 6 sub-steps for collision detection and response. For a stress test, we draw more deformable models more rapidly. The scene is composed of 52 deformable models with approximately 4,000 particles and 18,000 edges. The simulation runs at over 30 frames per second. The last example demonstrates the effectiveness of our technique as an embedded space deformation technique. This example employs a smaller number of particles for each deformable model than the previous example to simulate a larger number of deformable models. In this example, each dinosaur, bunny, and armadillo is made up of 30 particles, and each torus is made up of 12 particles. In the previous example, each of them is made up of 100 particles. Nevertheless, the simulation is robust and responsive. The simulation runs at over 30 frames per second.